because I think there's 1 or 2 people in the chat right now. Come on. There we go. And we're live. And it looks like we got 1 person there. And they can say something in the chat to say hello when they're ready. And I can see who people are and things of that nature. But we're going to get going with this lesson today. Okay. Last week, we did a little re-intro to mathematics and algebra and things of that nature, and we took that quizzes, which was fantastic. That did give me a good deal of information. This week, we are going to be jumping headfirst into quadratics, as I said. Before we jump into that lesson, a couple of reminders. Number 1, online textbooks. I have most of you. Already signed up for that online textbook. And if you got the thank you from me, then yes, I saw that you signed up and we're good to go. But I need to make sure everyone is signed up for that online textbook because starting next week, I am going to be assigning you various things out of it. So please make sure that you are doing that. Second, there was a snafu with the benchmarks. A wonderful snafu where there was an email sent out originally and then a second email that contradicted that original email and then a third email clarifying that second thing, trying to show how it didn't contradict the first one, but it actually did. And then finally another email yesterday which clarified the clarification. I'm not even joking. That's literally what happened. So originally there was supposed to be a benchmark on geometry information. Unfortunately, much to my chagrin and much to my yelling in the hallway yesterday, I don't know if any of you were even in C-Wing yesterday, but I was yelling at some point. But much to that just aggravation, I had to change the code for the benchmark, and it actually ends up being, hey guys, you know that class Algebra 2 that you haven't actually taken yet? Your benchmark is on information that you would learn by the end of the school year. So, you know all that information you never learned? Here's a benchmark. Try your best. That doesn't make any sense. I know. But that's my job. It's phenomenal. So the code is on there. I believe it's available until, hold on. Somebody double check this for me. When's that code available for the benchmark? I think it's Thursday. If you're on Google Classroom, you just click. There it is, Thursday. Due Thursday. It's the updated READ for the week. There we go. Yeah, that's fun. But yeah, that's what my supervisor wants. So make sure you follow those directions and get that thing done before Thursday at 2 o'clock, and that would be phenomenal for me. Today's Tuesday, right? Oh, thank God. Oh, thank God. Yeah, so anyway, it's Tuesday, but you have until Thursday to get that done. So number 1, online textbooks. Number 2, get that benchmark done for me. That would be phenomenal. And we could jump into this. Now, what I need from you, ladies and gentlemen, as I said, it's going to be a little bit of a notish heavy day. But at certain points, I may, at the beginning of a class period, I may ask for those notebooks. And I'll typically do it in a very similar fashion like I did a little bit last week. But I want to make sure I get this routine down since I'm only seeing you once a week. When I do ask for the notebooks, obviously, I will ask for those notebooks to be out and open. Now, yesterday, I had cohort 1, and I asked for those notebooks to be out and open, and there was like 3 or 4 students who didn't do anything, and they just kind of sat there. And I'm like, I wonder if they heard me. And I said, like, notebooks out and open, and they're just like, and I looked at one kid, and I'm like, what's the deal? And he looks at me, and he's like, I don't have a notebook. So I'm not saying that you're one of these students, but if you are, I have no problem with that, but please speak up. Say like, I have a notebook. Thank you for letting me know rather than just standing there like a moron for a few minutes trying to wonder why you're not taking out a notebook. If you don't have a notebook, watch this. If you don't have a notebook, I got you covered. You can keep it. Whatever you need, I got them. I got binders, I got notebooks, I got pencils, I got erasers, I got paper. I got whatever you need. So, if you need a notebook, just please simply ask. Just don't just sit there waiting for me to say something. So, yes. Thank you. Absolutely. Go ahead, get it. Absolutely. But that's what I'm saying, because like the kids yesterday just literally sat there and did nothing for like a couple of minutes until I said, like, what's the deal? That's yours to keep. They came from every year teachers get a certain amount of money in their budget to buy stuff, and I always buy notebooks, So absolutely. So ladies and gentlemen, if you would, if you do not already have them out, I'm gonna need those notebooks out and open. There we go. Y'all see the only football game that mattered over the weekend? Wait, which game? That's not the only game that mattered. That's not the only. Ravens. The only game that mattered. Oh, yeah, dude. I've been a Ravens fan since they drafted Joe Flacco. I was living in Northern Maryland, and the radio station, and the radio station was just saying, like, who's going to save the Ravens season? Joe Flacco. And I'm like, that's the coolest name ever. At the time, he was the third string quarterback. Yeah. And he's a Super Bowl champion and on the injured reserve list for the Jets. Whatever. But Lamar Jackson, oh man, mark my words, Lamar Jackson's going to be better than going to be more remembered than Tom Brady. Just saying. All right, let's jump into this. Oh, that's what I wanted to do. For those of you in the chat, I am going to bring up the chat on my phone so I have it not only on the computer in the front, but I also have it in front of me right here. So if you're going to say something in the chat, I can still read it. There we go. So look, Inception. That's the chat. No one said anything, but I got 4 people live in the chat. Look, it's an Inception. Look, every little screen, it's going to like bring my phone on. That's so weird. Anyway, back to this. Why do they let me do this job? All right, today's the 15th. I'm always going to give you a date, and I'm always going to give you a title. This is a reintroduction to quadratics and factoring. As always, I'm going to try and work around the giant glare that is in the middle of the screen. Again, unfortunately, there's not much I can do about it right now until they allow me to work off of OBS Studio. Once I can work off of OBS Studio, I can actually work around this stupid glare that's in the middle of the screen. But until then, this is the problem that I have. Can you imagine how awesome would it be if you had a live stream where in one little corner, there's my face. And then in the rest of the screen, there's like the thing that I'm working on. And then I do 1, 2, click. I click 2 things on the computer and then bam, I could show you like a different screen. It'd be awesome, all on one live stream. And then like click, click, I just muted them. Like life would be so much easier. Anyway, back to this. Let's talk about a basic example. Basic. Factor. Let's say I wanted you to factor the number 48. Now, this is something that you guys did back in middle school, probably like pre-algebra stuff. Not even pre-algebra, maybe like even 6th grade math. I have no idea. But if I ask you to factor something like this, I might say, cha-cha, cha-cha, hey, factor tree. Hey, give me 2 numbers that multiply to 48. Sure. Can I break them down farther? Yeah. Absolutely. And that's the whole point. The whole point of a factor tree is to break down the number as far as it can possibly go. The 6 can break down to a 2 and a 3. The 8 can break down to a 4 and a 2. And the 4 can break down to a 2 and a 2. This is called prime factorization. Now, I said this is a reintroduction to quadratics and factoring because, well, You have been introduced to quadratics at some point, but I need to reintroduce you to the topic. In the end, the prime factorization of 48 would be equal to 2 times 2 times 2 times 2 times 3. And these would be what we call the factors. Let's bring that down just a little bit for the people in the live stream. But these would be considered the factors of 48. When you break things down into factors, they are broken down using a series of multiplication. 2 times 2 times 2 times 2 times 3 is completely broken down, ripped apart into its prime factors. If you were to multiply these back together, you would get 48. And I'm going to show you that in a little bit with quadratics. In fact, 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 3 is 48. Doesn't matter what order you multiply them in, it still works. Prime factors. Oh, happy day. But then, I bring back something from your past. I bring back something that's going to introduce a lot of PTSD into your life. I bring back a quadratic. See if I can fix that computer screen a little bit better. That's a tiny bit better. But you see a quadratic. Yes? Absolutely. Yeah. Is it on its last legs? Yeah. Yeah, I keep forgetting to remind you guys, if you need to charge anything, charge something. Yes, But this is a quadratic. Now, this quadratic has so many different properties to it. This quadratic, if you were to graph it, would have a certain shape to it. Where'd it go? There it is. This quadratic, let me try to bring this up here. There it is. I'll zoom in on the calculator. Ta-da! This quadratic is in a certain form. It has multiple variables. It has an exponent. If you were to graph it, it would look something like this. Hey, what shape is that? Y'all remember what shape that's called? Parabola. Parabola. But it's a parabola. It's a U shape. It has a vertex. It has 2 x-intercepts. Eventually, we're going to deep dive into these, but again, this is about reintroducing the concept of factoring, which is going to play a role in a lot of different sections that we're going to be covering in the next couple chapters. So I need you to be on top of factoring. The general concept behind taking an equation that is a quadratic and factoring it is doing something like this. I'm going to take this entire thing, and I am going to break it down in a similar fashion that I did 48. You could take the number 48, you could break it down into its prime factors. Well, for a quadratic has slightly different prime factors. In this example, the prime factors of this quadratic are x plus 3 and x minus 2. Mr. Markey, how'd you do that? I'm going to show you in a little bit. Don't you worry. These are what we call the factors. Hey, just for the sake of argument, just kind of a little nugget of information. What's the smallest prime number? What's the smallest prime number? Ooh. People don't want to say it because they don't want to be wrong. You don't want to be wrong. Say a number. Sure. A lot of people say 1. 1 is not a prime number. The definition of a prime number is a number that is only divisible by itself and 1. But 1 is only divisible by 1. A prime number only has 2 factors. The idea of these prime factors means they cannot be broken down any farther. They cannot be broken up any farther. Yes, technically I could be like, oh, 1 times itself, but that doesn't help. 1's not a prime number. You'll see. How do I know I'm right? How do I, Mr. Markey, a math genius, know that I am correct in saying that these 2 factors work, that they are the factors of this original quadratic? Well, let me go back a page. How do I know I'm right here? How do I know that these numbers are indeed the factors of 48? How do I prove that I'm right? Exactly. Guess what? You can prove, oh, what he said for those in the chat, he said multiply them and you get 48. I can multiply these 2 back together. I can. I don't know how you multiplied prime factors back in the day. I have no idea how you multiplied prime factors back in the day. If you know a way, go for it. Go for it. But you can check by multiplication, where I'm going to take x plus 3 and multiply it by x minus 2. I'm going to check to make sure that I'm right. Man, how do you multiply those 2 back together, Mr. Markey? Well, there's a few different ways. Some of you guys may have learned FOIL. Any of you guys learned FOIL? I don't like it. You know why? Hurts my teeth. Just saying, don't do it. You ever chew tinfoil? Don't. Anyway, but you can do FOIL. If you prefer FOIL, go for it. But this lesson's not on FOIL. You ever do lattice multiplication? It's dumb. Lattice multiplication is dumb, but it works here. Check this out. It's a good organizational tool. You could also call it a Punnett square or some junk like that. It's a good organizational tool for multiplying polynomials together. Mr. Markey, that's nothing more than FOIL. I know. FOIL works if you have 2 binomials. But if you don't have a binomial, FOIL's not going to work. Just saying. That's up to you. You want to use FOIL? Use FOIL. You want to use a different method? Go for it, as long as you're correct. I'm going to be very clear about something. I am not going to force you to learn a method that I like when you already know a different method. If I teach you one way and you've learned it a different way and want to stick with that, go for it. As long as you're correct and as long as you can back up your work, I don't care what method you use. I don't. Today, I'm going to reteach you a method of factoring. Mr. Markey, I know a better method. Go for it. If you know a better method that works for you, do it as long as you're correct. Anyway, I got to check my work. Multiply. I get a little x squared going on up there. 3 times x, I get 3x. X times negative 2, I get negative 2x. 3 times negative 2, I get negative 6. And then I get 3 magic words that I have to use. Combine like terms. If I combine those like terms, I get an x squared plus, 3x and negative 2x make positive 1x, and then a negative 6. It works. Confirmed. I've confirmed. All I've done is confirm that I'm correct.
So like when you first factored them, you got like the 3 and the negative 2 from the 6, the negative 6.
I'm going to get there.
Okay.
Here's what I want you to take away from this. Technically, I have not shown you how to do this. If you know how to do it, perfect. This right here, this page is not showing you how to do it. It's not. What this page is really showing you is this. Factoring. Factoring is the act of taking a number or an equation and ripping it apart to its prime factors. Then, if you wanted to multiply them back together, that's literally just shoving them back together. Math is violent. It can be. Math is very violent, you know? Just saying. You ever tried to divide by 0? Yeah. What's crazy is that on the graphing calculators, if you tried to divide by 0, there is an audible, like electronic, like zzz, because you can't divide by 0. it prevents you from dividing by 0. Yeah, but I'm just saying, but but the calculator stops you and says error. If the calculator let you do it, the world would blow up. I'm saying every time you divide by 0, you're risking the planet. Facts. Anyway. You're going to learn very quickly never to trust anything I say, including what I'm teaching you right now. What I'm teaching you right now is just like fake. Mr. Markey, then how are you? Sorry. Oh, I have too much fun with my job. Factoring quadratics is, quote, breaking down, end quote, equations into its prime factors. This is what factoring quadratics is all about. Now, there is an application to it. The application that we are going to apply to factoring quadratics is going to allow us to solve quadratics. But that's for another lesson. We're going to get there. Right now, I want to walk you through factoring. I may have mentioned this last week, but did I mention the Tucker method? Good. I did not show you how. I did not show you how, but I want to walk you through the Tucker method. Now, this is going to be twofold. It's going to be twofold. First, I'm going to walk you through what the Tucker method looks like. Then, I am going to write down the steps of the Tucker method. I'm not going to show you the steps first. First, I'm going to walk you through it. I'm going to walk you through it. So here's an example from your worksheet, the PDF file that I have in Google Classroom. It was an x squared plus 7x minus 18. That is a quadratic. I'm not sure why they call them quadratics. It's not a joke. I'm not setting up for a joke. I just legit don't know why they call them quadratics. Think about it, like quad. What's quad typically mean? Yeah. Right? Like, no, I know, but squared is 2. You know? Maybe because a square is 4 sides? I don't know. Whatever. Anyway, back to this. Sorry, I'm losing my mind. Here's the walkthrough of the Tucker method. There is a certain step that I'm going to skip right now because it doesn't apply. I'm going to come back to it. But then you do a little A times C action. Mr. Markey, what's the A and what's the C? I'm getting there. I'm getting there. Hey, what happened to the live stream? Oh, back online. Never mind. A times C gets me negative 18. Mr. Markey, what do I do with that negative 18? How does that negative 18 help me? Well, it helps you like this. I need 2 numbers that multiply to negative 18. Name any 2 numbers. Any 2 numbers that multiply to negative 18. Negative 9 times 2. Keep going. Say again? Any. Negative 6 and 3. Name another. There are technically 6 answers. 6 that you could give me. Yeah, you switch the negative. Because he switched the negative on his. Yeah. By the way, the answers that were given for the live stream. Oh, there's one in the chat right there. Absolutely. Sorry, I'm just looking at the chat while they're doing it. The answers that they've given me in class so far are negative 2 and 9, negative 9 and 2, 3 and negative 6, and negative 3 and positive 6. But there's 2 other possibilities. Yes, you can. 1 and negative 18, and then negative 1 and positive 18. That works. Ms. Markey, you can't do that for factorization. I know. We're not there yet. But listen to the question. I just asked, give me 2 numbers that multiply to negative 18. I didn't specify whether they had to be prime or not. Think about the 3 and the 6. 6 isn't prime, right? 6 isn't prime, but you can still do it that way. Here are the numbers that I need, though. The 2 numbers that I need are 9 and negative 2. I do see in the chat there, because I got the little chat screen open for myself. Now, some of you were like, oh, I get it. I think I get it. Okay, all right, shut up. You know, check this out. Again, this is the walkthrough of the Tucker method. I'm going to go through the steps with you in a few minutes. That's a T-chart, and I put those two numbers in the bottom of the T-chart. Mr. Markey, what are you going to put in the top of the T-chart? I'm glad you asked. I'm going to put a 1x and a 1x. Where did they come from? I'll tell you later. I'll tell you later exactly where they came from. But check this out. There we go. I'm going to move that up a little bit, and I'm going to talk about what the heck I just did. Margie, what the heck did you just do? Oh, no, shut up. I'm going to tell you exactly what I did. This T-chart is very precise. I need to show you in a little bit exactly how that T-chart works, how you put it together, and how it's simplified. But then I drew these little arrows at the bottom, because right here I have a 1x, and I have a 9. I have a 1x and a 9. I have a 1x and a positive 9. Boom, x plus 9. I have a 1x and a negative 2. A 1x and a negative 2. X minus 2. This is the factored form. Those two binomials, the x plus 9 and the x minus 2, are the factors of my quadratic. They work. Now, you were asking before about those numbers and like what they had to do, multiply, add to, stuff like that. Yes, for the most part, you were absolutely right there. You're absolutely right there. There's a few caveats to the whole thing. There's a few extra little addendums that I have to put on top of that, which I'm going to get to. Oh, it's going to be so much fun. For me, not for you. I'm just having fun with my job. Again, it gives me immense joy and pleasure to teach high school students fake math. You know, because then do you know whether or not right now whether this is real or not? You don't know if this is real or fake. And by the end of the year, you're going to be like, oh, crap, the whole class was fake. Why do they let me do this? Because I'm convincing at my job. If I can con my way into teaching a high school math class, what can't I do? I had you all believing that I'm half Puerto Rican, which I am. You should meet my mom. My mom is what you would call, there's two types of Puerto Ricans. There are light-skinned Puerto Rican and there are dark-skinned Puerto Rican. Dark-skinned Puerto Rican are native islanders. Their ancestors have been on the island of Puerto Rico for thousands of years. I don't even know how long. Like they came over on the ice bridge through Alaska. You know what I'm talking about? But then there are light-skinned Puerto Ricans, and they're the ones that came through Spain and Europe and stuff like that. They came over with the settlers and the colonists and junk like that. My mom is a light-skinned Puerto Rican. So anyway, fun fact about my mom. She grew up in Puerto Rico. She grew up in the middle of the island in a village called San Sebastian. She told me that the first time she ever saw the ocean was when they left the island to come to New York. Think about that. You grow up on Puerto Rico and you never see the ocean until you leave the island. That's messed up. But that's the town that they grew up in. So anyway, there are 5 steps to the Tucker method. I'm going to walk you through each of them. They're phenomenal. I love the Tucker method. Who was Tucker? I don't know. I have no idea. The first step to the Tucker method is 3 simple letters. GCF. What the heck is GCF? I haven't even mentioned that today. Greatest common factor. Now that is the reoccurring theme of today. Why is my phone buzzing? Stop adding private comments. Gosh. I have an assignment in a different Google Classroom that's due today at like 2 o'clock. And the kid emailed me today asking if he could get it done after practice. It's been like on Google Classroom for over a week. Get your stuff together. Anyway, I'm losing my mind today, if you can't tell. Greatest common factor. That's the theme for today. Factor. Factor, 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 factor. Greatest common factor. We're going to talk about that when we get to the next example. Step 2. Step 2 is A times C. Where does the A and where does the C come from? AX squared plus BX plus C. This is the general form of a quadratic equation. The general form of a quadratic equation is in the form AX squared plus BX plus C. The A is always with the X squared, the B is always with the X, and the C is always by itself. Now, you don't have to use X's. You could use whatever you want, but I'm just sticking with that. Step 3 is the most important step. Step 3 is the most important step. Step 3 is where you get your magic numbers. Magic numbers are what it's all about. Those are the two numbers that I was asking you for before. The two numbers where we were trying to find that multiplied to negative 18. But there's only one set of magic numbers. These magic numbers, they have to multiply to AC, and they have to add to B. Those are the questions that you were asking me before, but again, that's only one of the steps. The two magic numbers, they have to multiply to AC, and at the exact same moment, they have to add up to whatever the B value is. Step 4. Now, step 4 is a little weird. Step 4 is where you organize stuff into the T-chart, which I'm going to go into more details in a little bit. But there's an extra caveat. When you organize the T-chart, there's an additional step to simplify. I'm going to go into many more details about simplification in a little bit. Just know that these are the steps. Step 5 is to write your factors. After you have simplified, or if you could simplify, your goal is to then write out the factors. Now, depending on what the question is asking, you may have to do more stuff. Maybe the question will then ask you to graph. Maybe the question will then ask you to solve. I don't know. But at this particular point, these are the steps for factoring. These are the steps for the Tucker method. This is what we're going to be focusing on. Now, some of you, again, may know a different method. That's fine. Use that other method. But the Tucker method is so nice. It is so nice. It applies to all types. Back in Algebra 1, I want you to think back. Back in Algebra 1, did you ever learn like different formulas for quadratics, like the difference of two squares or perfect square trinomials or some junk like that? Maybe. Kind of somewhat coming back to you a little bit. I don't teach those formulas. I don't. You know why? This takes care of it. All of this takes care of it. You don't have to worry about those formulas. I will eventually teach you the quadratic formula. You all know the quadratic formula? Negative b plus or minus square root of b squared minus 4ac all over 2a? Yeah, you're going to have to learn that. But those extra little formulas, those formulas like a squared minus b squared equals a minus b times a plus b, or a squared plus 2ab plus b squared equals a plus b quantity squared, or some junk like that. I don't teach that. I don't see the point. Because if you know the Tucker method takes care of that. You don't have to do that. Garbage. It's not garbage. It's just like an extra little thing. You'll find that the formulas that I end up teaching you in class are the ones that I deem worthy. They're the ones that I deem necessary. They're the ones that I see as being important. But I'm not going to teach you a formula if you're never actually going to need it. You know? Anyway, let's talk about an example. Let's see. Chapow! Example. Oh, wait. Yes. Hold on. I got to think about this for a second. Yes, I'm going to do that. 2x squared plus 3x minus 5. That is the example that I want. I changed the example from the one that I did yesterday. I slightly changed it. But let's walk through the Tucker method. Let's walk through the Tucker method. Now, when I say greatest common factor, what you want to do is you want to look at all three terms in the equation. And you want to ask yourself the question, is there something that I can divide out of all three? Is there a common number or variable that I can divide out of all three terms? I see a 2, I see a 3, I see a 5. What can I divide out of all three? What could I divide out of all three of those terms? Mr. Markey, nothing. No, there's something. You could divide a number or two out of them. Do you know what it is? It's just 1, yeah. Or -1 if you wanted to, but let's focus on 1. Yeah, you could divide a 1 out of all three. But when you divide by 1, what happens? No, when you divide by 1, nothing happens. Nothing happens when you divide by 1. 5 divided by 1, 10 divided by 1. Nothing happens. So I don't have to do step 1. Move on to step 2. All right, moving on to step 2. Step 2, I take the A value and I multiply it by the C value. All right. A times C is 2 times -5 to get me -10. Yay, we did it. We did step 2. That's literally all that step 2 is. All right, step 3, magic numbers. I need to find 2 magic numbers that multiply to -10 and at the exact same moment add up to the B value, which in this case is +3. Yeah. -2 and 5. Not the two numbers I started with, but -2 and 5. Sometimes that happens. Sometimes it doesn't. I don't know. -2, +5. They are my 2 magic numbers. Yes. Because again, they multiply to give you -10, and at the exact same moment, they add up to the B value of +3. Yay, we did step 3. Woo! Step 4, T-chart. Whenever you find those magic numbers, you always drop them in the bottom of your T-chart. You always drop them in the bottom of your T-chart. But what goes on the top? Now, a little bit of an issue here. When I look at that first term in the quadratic, I see a 2x squared. I see a 2x squared. I could break that 2x squared down. I could break that 2x squared down into a 2x and an x, or an x and a 2x. I don't know which one needs to go where. It's a 2x and an x, or an x and a 2x. I don't want to think about it. I don't want to think about it. I want a simple way of getting this thing done. Here's what I'm going to do. I'm not going to make a decision. I'm not making a decision as to whether it's 2x and x or x and 2x. Instead, I'm going to put a 2x in both. I'm going to put a 2x in both. Mr. Markey, why? Well, for the time being, this be a 2x squared. Because of that 2 in front, I'm going to bring a 2x and a 2x here. They're not going to stay. Because what's step 4? It's T-chart and what? Simplify. We're going to simplify some junk out. We're going to simplify some junk. When you think simplifying in math, what do you typically think of? What do you simplify in math? Second? Fractions. I don't see any fractions up here. Do you? Oh, interesting. What's in the middle of a fraction? The bar, right? There's the bar. It's a hidden fraction bar. The reason why I say that is this. 2 and 2. Can you simplify that? Oh, heck yeah. Heck yeah. Here's what I'm going to do. In mathematics, let me just recap what I just said. In mathematics, you simplify fractions, as you said. What's in the middle of a fraction? A fraction bar. You're going to temporarily... Am I frozen? Yeah, I'm frozen. Like my heart. There we go. Am I still frozen? Do y'all see that? Well, exactly. You don't see it. Hold on. What the heck? Y'all frozen. Am I back? Yeah, I'm back. Okay. Sorry. The screen froze on me. It's all good. Right here, you treat that like a fraction bar, and that's a 2 over a 2. 2 over a 2. Ignore the negative. Ignore the negative. What's 2 over 2 simplify to become? Over 1 over 1, right? My red pen. There's my red pen. That simplifies to become a 1 and a 1. The negative stays on the bottom. What about this 2 over 5? Does 2 over 5 simplify? Nope, leave it. Leave it. If 2 over 5 doesn't simplify, leave it. Now I'm ready. Now I'm ready. Right here, since I simplified, it's no longer a 2x, it's a 1x. And down here, it's no longer a minus 2, it's a minus 1. This becomes 1x minus 1. And in the other one, nothing simplified, so it becomes a 2x plus 5. There it is. This is ridiculous, Mr. Markey. What the heck is this? This is the Tucker method. The 2x squared. Yeah. Exactly. So like, for example, you know, on step 2, it's at ax squared. Yeah. Technically in the t-chart, it'd be like an ax and an ax, but then the a might simplify. Yeah. This is ridiculous. I'm going to check to make sure that I'm right. I want to make sure that I'm right. I need to make sure that I'm right. If I'm right, then I should end up with exactly what I started with. It's a negative 2x and negative 5. What's that make right there? What do these two terms make? No, when you add them together. 3x, positive 3x. That's the middle term. 2x squared plus 3x minus 5. I'm correct. I like being correct. Notice I'm not writing that into my notes. I was just double checking to make sure that I was correct, which I knew that I was. 99.99% of the time I'm correct. Do you know what happens the other 100th of a percent? I'm still correct. I just fake it. Even if I'm wrong, I'm still going to convince you that I'm right. Do you believe me? Ooh, just you wait and see. Just you wait and see. All right, now for one of those formulas. You know the formula that you didn't want to memorize? That I told you don't have to memorize? Yeah, watch this. I have 2 more examples that I want to show you, and then I want you to try something on your own. Example. X squared minus 100. This is an example of back in Algebra 1, they'd be like, hey guys, memorize this extra formula. Screw that. I'm not going to have you memorize an extra formula. Screw that. Instead, I'm going to ask you the following question. What looks weird about this equation? What's weird about it? Is there anything wrong with it? Why doesn't it resemble what we've done before? No, it's a 1 variable. It's an x squared. There's 2 terms. When there's usually 3. What's missing? Say again? In the middle, right? ax squared plus bx plus c. There's the ax squared. There's the c. What's my b value? It's a 0. It's a 0. My b value in the middle, it is technically a 0x. So I'm going to keep going with the Tucker method. The Tucker method, step 1, asks me to take out a greatest common factor. In this case, it's a 1 and 100. Sorry, the GCF is 1. Skip it. Go to step 2. Step 2. Step 2 is A times C, where I get negative 100. I need 2 magic numbers that multiply to negative 100 and add up to that B value that you said was 0. 2 numbers that multiply to negative 100 and add up to that B value of 0. Negative 10 and 10. Negative 10 and positive 10. The beauty of the Tucker method is that once you get it down, I see you in the chat. I see you in the chat. Good job. Sorry, I'm just talking to the chat people. But the beauty of the Tucker method is that it doesn't take a lot of writing. It just takes a little bit of thinking. And if you can get that little bit of thinking down, you're golden. There's a 1x and a 1x, a 10 and a negative 10. Nothing simplifies. Done. It doesn't take a lot of writing. It just takes a little bit of thinking. That's the beauty of the Tucker method. Somebody give me a single-digit number. Any number. 7. Okay, hold on. X squared plus 7x. Somebody give me another single-digit number that's not 7. 5. Minus 5. Check this out. Check this junk out. I can't take out a GCF. A times C is negative 5. Give me 2 numbers that multiply to negative 5. Any 2 numbers. Any 2. That multiply to negative 5. 5 and negative 1. Let me write that down. Hold on. 5 and negative 1. But what do they add up to? 4. That doesn't work. Okay, different pair. Give me a different pair of numbers. A different pair of numbers that multiply to negative 5. Negative 5, positive 1. But what do they add up to? What do I need them to add up to? Growl. Are there any other numbers? What does this mean? Huh? Not that it's already simplified. I don't want to use that term. I want to use a different term. The term that I want to use is not factorable. It's not factorable. And the reason why I was able to prove that, is because I listed out all of the terms that might work, but they don't. They don't. These are the only terms that could work, but they don't work. They don't add up to 7. And as a result, this thing is not factorable. It is already what we call prime. It's a prime number. It's a prime quadratic. It's amazing. It's amazing. That laugh sounded a little bit like SpongeBob, and I'm a little scared now. Agree, disagree? No? Whatever. You ever see the SpongeBob musical? You have not lived until you've seen the SpongeBob musical. It's so good. It's just good, right? It's good. Anyway. Anyway. All right. Here's what I want to do. I want to wrap up with 2 problems, but this wrap up is going to take a little bit of time. So I'm going to split my page. what I'm going to do is I want to give you 2 problems. And I'm going to get you started on one of them. I want to get you started on one of them. Actually, kind of on both of them, but we'll see. There we go. I'm going to get you started, and then I'm going to have you finish these 2, factored completely. So here's the deal. Mr. Markey, look, there's a 4 and a 4. They both have a 4 in common. I did it. I'm sorry, does that 15 have, can you divide that 15 by 4? Nope. You can't take out a greatest common factor here. You cannot take out a greatest common factor in this first problem because they all have to have it in common. But look over here. 4, 4, negative 24. These all have a 4 in common. So what you do is this. Greatest common factor. You have to divide out the greatest common factor first. But notice where I put it. I left it up front. Leave it there. Then you are to do the rest of the Tucker method. But this time, you are to solely focus on what is inside of the parentheses. You are to focus on what is inside of the parentheses. That 4 is inconsequential at the moment. That 4 is no longer needed for the time being. You just leave it there and you perform the rest of the Tucker method with what's inside the parentheses. I'm going to give you a few minutes. I want you to finish both of these problems. Finish both of these problems in its entirety. Tucker method, factor them down. I want to see correct answers. Go. I'm also obsessed with King George III from Hamilton, just for the record. Which led me on a really weird rabbit trail back to Glee. Don't judge me. Negatives and positives are going to make all the difference in the world with these problems. You want a weird, like, round circle thing? Check this out. Remember in the beginning of this lesson where I said, hey, here's a quadratic, and I'm going to factor this, but I'm not going to explain how. But I said I'm not going to explain how just yet. What quadratic was that? You remember? In your notes. Yeah. It just blew your mind. It's like I know what I'm doing or something. The thing is, again, on the front page, I didn't explain how, but now you have the skills to get this done. Yeah. two numbers that are multiplied to negative 6 and add up to positive 1? They work. If you're wondering in the chat what we're doing, I gave you these two problems to complete using the Tucker method. I'm going to walk you through the answers to these in a few minutes. I just wanted to give you an opportunity to finish them on your own. All right. Let's talk about what we did right and wrong here. First, let's start with the first problem that has the minus 15 at the end. There was no GCF to take out, so I did A times C, and I got negative 60. Oh, Mr. Markey, what a terrible problem. Negative 60, I'm not going to be able to do this one. Two numbers that multiply to negative 60 and add up to positive 4, how is that even possible? You shaking your head no? Why? I feel like he's playing coy with me. I don't know. What do you guys got? What two magic numbers could possibly work in this situation? Does he have it though? Or is he just playing with me?
I think 6 and negative 6.
Okay. Yeah. See, he was playing coy with me. Let's all beat him up after class, okay? Y'all down with that? No? Fine, it'll just be me. All right. Anyway, T-chart. Negative 6 and 10. Now here's the key. I could not take out a greatest common factor. I couldn't. Which means, what do I put in the top here? What do I put in the top of that T-chart this time around? I can't put X and X. I can't. Ooh, what'd you guys put? 4X and 4X. You got to put a 4X and a 4X here. The 4X and the 4X came from the 4X squared. I had to do it that way. But now comes a slew of simplifying. Let me zoom in a little bit and show you that slew of simplifying that has to take place. 4 over 6 reduces to a 2 over 3. Make sure you leave the negative in the bottom. 4 over 10 simplifies to become a 2 over 5. And as a result of simplifying both of them, which you have to do in this situation, you have to. If you can simplify, you must simplify. As a result, this should be a 2x minus 3. Don't lose the negative. Do not lose the negative. And a 2x plus 5. Those are my factors. Those are my prime factors, which are going to play an important role moving forward with these quadratics. Again, this is a reintroduction to factoring quadratics because, oh man, the stuff I'm going to be showing you and giving you as assignments is going to be amazing. Ooh, I get to give you a project. Not today. Not today. But I do get to give you a project with this chapter, which I am oh so excited for. Let's go back to the other problem now. In the other problem, I was able to take out a 4 as a greatest common factor. You leave the 4 out front. A times C got you negative 6. As I talked about before, this is technically the problem that I started the class with. This is the problem I started the class with. This quadratic right here. 3 and negative 2 are indeed your magic numbers because, somebody tell me verbally, what's my B value for this problem? Yeah, well, technically just the 1. Yeah, just the 1. But it is 1, though. You got to recognize that 1 right in the middle. T-chart, X and X, 3 and negative 2. Again, the reason why it's an X and X is because this is just a 1x squared. This becomes x plus 3 and x minus 2. I want to tell you something very important right now, something so important and life-changing that's really going to mess with your heads. If you left your answer as this, I will mark it wrong. If you left your answer as this, I will mark it wrong. Somebody tell me why. Why? Exactly. The whole concept that I'm reintroducing you today is factoring. Factoring, factoring, factoring. The Tucker method is one version of factoring quadratics. But when we took out that 4, and you even just said it before, you called it what it was. We took out the 4, and you called it the greatest common factor. That's the key. That 4, that positive 4, counts as a factor to this problem. So, as a result, I bring that 4 down because it counts as a factor to this problem. It counts. Don't you lose it. Again, this is the Tucker method. Some of you may have been taught other methods. By all means, if they work, they work. If you were taught a different method and want to stick to it, keep it. Absolutely. I'm not going to mark you wrong as long as you have work to back up what you're saying. This is the Tucker method. Later on this week, I am going to have things for you to do on Google Classroom. Make sure you stay tuned. Make sure if you haven't gotten that online textbook, you get that online textbook. But in the meantime, besides any of that, the benchmark, couldn't think of the word, the benchmark should be your priority. Again, I apologize for the difficulty of the benchmark. I apologize for the terribleness and the rotten taste that it will leave in your mouth. But the benchmark is something that I need my Algebra 2 classes to get done. It will not count against you. It will not count against you, but I do need your best effort on that benchmark because my supervisor is going to look at the results. Yay. Anyway, that's it for me. I'm about to sign off in that chat. You guys can pack up if you got them. Don't forget your Chromebook that you plugged in because people tend to leave stuff and I don't want them to leave stuff. But anyway, I'm going to sign off. And if you have any questions, you can always email me. Like, share, and subscribe. I don't know, all the good stuff. I'm signing off. Click.